All right, today's video is on section 3.5, which is derivatives of trig functions. And what this really comes down to, guys, is a whole bunch of stuff that you just have to memorize. So we'll still be using our product and quotient rules, but really the new thing here is just memorizing the derivatives of these trig functions. So whatever works for you, doing flashcards or whatever you need to do, these just have to be pretty automatic. Okay, so here's some of the derivatives. We have 6 derivatives for our trig functions here. So the derivative of sine x is cosine of x. The derivative of cosine of x is the opposite of sine of x. Derivative of tangent x is secant squared of x. Okay, so that's equivalent to saying secant of x times secant of x. Okay, so derivative of, I'm going to jump down here, cotangent of x is opposite cosecant squared of x. The derivative of secant x is secant of x times the tangent of x. And last but not least, we have the derivative of cosecant of x, which is the opposite of cosecant of x times cotangent of x. And so again, those are just rules you're going to have to memorize. And really you can kind of break it down. If you know sine, tangent, and secant, then you know their cos are just the opposite. And like if I look at tangent, my derivative is secant squared of x. The derivative of cotangent of x is opposite, and it's just cosecant squared of x. So if you have the basic ones, then you should be able to get the other half. So let's go ahead and work some basic problems. We'll start off simple, and then we'll work up to where we have to find derivatives using product or quotient rule or finding higher order derivatives. So this first group is just basic derivatives. So here I have the sum of two functions, so I know its derivative is just the derivative of those two functions. So derivative of sine of x gives us cosine of x. The derivative of cosine of x is opposite sine of x, so I'm going to have minus sine of x for my second term. For my second one, f prime of x, I know the derivative of a constant times a function is just a constant times the derivative of that function. So my derivative is going to be 3 times the derivative of tangent of x, which is secant squared of x. Okay, for number 3, here again I have 2 terms in my function that I need to differentiate, but each of those terms again is just a constant times a function. So for my first derivative, I'm going to take my constant 2 times the derivative of cosecant of x, which I know is going to be the opposite of cosecant of x times cotangent of x. So I'm going to move my negative out front, and I have negative 2 times cosecant of x cotangent x. And then I'll deal with my second term. I have 4 times the derivative of secant x, which is secant x tan x. And that's my derivative. The last one for this section here, f prime of x. I have 3 times the derivative of cotangent of x. Since that derivative is opposite of cosecant squared of x, I'm going to have a negative 3 times cosecant squared of x plus 5 times the derivative of tangent x, which is secant squared of x. So those are the very basic level for these types of problems. So now we're going to move into some where we have to use either quotient or product rule to find the derivative. So I'm going to move my paper up here. So for number 5, hopefully we can all see pretty quickly that this is going to require us to use our product rule. Okay, so y prime is equal to my first factor, x squared, times the derivative of sine x, which is cosine x, plus my second factor, sine of x, times the derivative of my first, or 2x. And so there's not much I'm going to do to that, except I'm going to move my 2x in front for my second term. So my derivative is x squared times cosine of x plus 2x times sine of x. Okay, for number 6, now we're going to try one with the quotient rule. So just use different notation. My function is u, so I'm going to find du dx, which is just the derivative of u with respect to x. Again, I know I'm using my quotient rule here. So we know that is low d high, so the derivative of cosine x is negative sine x, minus high d low, so the derivative of 1 minus sine x is going to give me a minus cosine of x, all over 1 minus sine of x squared. So I'm going to go ahead and expand my numerator and see if there's anything I can simplify. So I'm going to distribute my negative sine x. I get plus sine squared of x. When I distribute my cosine x or multiply those, I get plus cosine squared of x all over 1 minus sine of x quantity squared. Now in these types of problems, we're going to have to be on the lookout for some of our trig identities. And so if I'm looking at this problem, I notice that I have sine squared of x plus cosine squared of x, which hopefully we all recognize is equal to 1. So I can simplify my numerator pretty substantially into 1 minus sine of x over 1 minus sine of x, quantity squared. And then I notice I can actually factor or cancel that factor of 1 minus sine x. So that's going to cancel out of the top. One of them is going to cancel on the bottom. So this whole thing simplifies to 1 over 1 minus sine of x. So definitely be on the lookout for those identities as you go through these types of problems. All right, so we're going to do a couple more. Again, same, just practicing product and quotient rules, and really the focus again is just getting down these derivatives of our trig functions. So for number 7, we have another product rule. So we're going to take secant x times the derivative of tangent x, which is secant squared of x, plus our tangent of x times the derivative of secant of x, which is secant of x tan x. And so now I'm just going to do some simplification. If I have secant of x times secant squared of x, I've got secant cubed of x. And then over here, I'm going to have secant of x times tangent squared of x. And for our purposes, we're just going to leave this here. We could factor out a secant of x out of each term, but I'm not concerned about that at this point. As long as we can get to here, that's what we need to be able to do right now. All right, moving right along, another quotient rule problem. So here we go. We have our low d high is secant squared x minus our high tangent of x d low, which is just 1 over x squared. So not much to do with this one. I'm just going to rewrite this as x times secant squared of x minus tangent of x all over x squared. And that's as far as we'll take that problem. Okay, more fun. Let's keep going. do these problems on this page. Okay, another quotient rule problem. So we have f prime of x equals low 2x d high. Our derivative of secant x is secant x tan x minus our high times derivative of our low all over low squared. And be careful that you put that 2x in parentheses, so when we square it, we're sure to square the 2 as well. So then we can go ahead and simplify. We get 2x secant x tan x minus 2 times secant of x minus 2 all over 4x squared. And so then I notice I can factor a 2 out of each term in the numerator and out of the denominator. So I'm going to go ahead and do that, which is going to give us a derivative of x secant x tan x minus secant of x minus 1 all over 2x squared. And that'll be our derivative. Oops, I made one mistake up here actually. So sorry, let's go back here when I was distributing. I have a negative times a negative 2. This should be a plus 2. So let's go back and fix that. Means this should be a plus 1 here. Sorry about that. All right, and one additional product rule example, quotient rule for number 10. So I have the cotangent of x times the derivative of my numerator, which is just 1, minus x minus 3. Now for the derivative of cotangent of x, I have negative cosecant squared of x, and that's all over cotangent of x squared. The only thing we can really do is get rid of those parentheses by distributing. So we'll have cotangent of x plus x cosecant squared of x minus 3 times cosecant squared of x all over cotangent squared of x. Okay, so the next two kind of go back to our original examples that we looked at in 1 through 4. So no product or quotient rule here. Again, this is just knowing your basic rules. So let's go ahead and look. These should be quick. The derivative of 3x we know is 3. Here we have minus 2 cosine x. Since the derivative of cosine x is a negative sine x, that's going to turn this into a positive 2 sine of x. And then we have 4. The derivative of cotangent of x is going to be opposite cosecant squared of x. So we're going to have a minus 4 cosecant squared of x. And then finally, for number 12, we have negative 5 cosecant of x. Since the derivative of cosecant x is opposite cosecant of x cotangent x, that is going to make this a positive 5 when we take the derivative. So we have a 5 cosecant of x cotangent of x plus 4 times the derivative of tangent x, which is secant squared of x. So that pretty much covers what you're going to be able to need to do with these derivatives of trig functions. The only thing we need to look at now is taking higher order derivatives involving trig functions. So we're just going to do a couple of those. Again, you're just following the same rules. You're just taking derivatives of derivatives. So for 13, first we're going to find y prime. And I know the derivative of secant of x is secant x tangent x. Now, what happens here is when I go to take that second derivative, I have to be careful because now I'm going to need to use the product rule here. So now I have secant of x times the derivative of tangent x, which is secant squared of x. And then I'm going to add the product of tangent of x and the derivative of secant of x, which is secant x tan x. And so I'm just going to simplify this a bit, and I think we've seen this one before. Secant cubed of x plus secant x tangent squared of x. All right, we have one more left to do. And this one gets pretty involved here, so you might want to go back and watch this one a second time. But let's see what happens when we try to differentiate y equals 2 sine of x times cosine of x. And we're going to find the second derivative. So the reason it's going to get pretty complex is because right off the bat, we notice that we already have to use the product rule to find our first derivative. So y prime, I'm going to lump it together so that my first function is 2 times the sine of x, and my second is going to be cosine of x. So I'm going to take my first 2 sine of x times the derivative of cosine x, which I know is the opposite of sine of x, and I'm going to add cosine of x times the derivative of 2 sine of x, which is 2 cosine of x. And now, I could combine those, but since I know I have to go ahead and take a second derivative, I'm not going to combine these at this point. So I'm going to leave them separate, and ultimately what's going to happen is now I have a problem where I have to do the product rule here, and I'm going to have to do the product rule a second time for this second term of my function. So let's see what that's going to look like. So now I'm treating this as my first, and here's my second function. So for this first piece, I'm going to have 2 times the sine of x times the derivative of negative sine of x, which is going to give me a negative cosine of x, plus my negative sine of x times the derivative of 2 sine of x, which is going to give me a 2 cosine of x. So far, I've just differentiated the purple part there. And I still have to deal with this piece here. So that's what we're going to do next. So now, I'm ignoring my first part. I'm going to take my cosine of x times the derivative of 2 cosine of x, which I know is going to be negative 2 sine of x. And then I'm adding the product of 2 times the cosine of x times the derivative of cosine of x, which is the opposite of the sine of x. So now I have all these terms, and I'm going to simplify and see if I can make this thing look a whole lot cleaner. So if I multiply these, I have negative 2 sine of x cosine of x. And then it looks like I'm actually going to have the same thing here. If I rearrange the order a bit, I have negative 2 times sine of x cosine of x. And it looks like this is actually going to end up being pretty easy to simplify because I have the same term over and over again. Again, here's my negative 2 sine of x cosine of x. And then here it comes again, minus 2 sine of x cosine of x. So if I combine my like terms, my derivative, my second derivative, is just negative 8 sine of x times cosine of x. So again, really the new piece for today is just knowing all the derivatives of those trig functions. So I would really encourage you to memorize those sooner than later because we're going to just assume that we know those and they are going to need to be pretty automatic. See you tomorrow.